Okay, I'll present 4 experiments that separately assess the time course of distractor processing and target processing within a flanker task. So, most, if not all, theoretical interpretations of attentional selection are intrinsically based on very specific assumptions about the time course of distractor processing and target processing during the course of a trial presentation. And yet, there are very few systematic direct investigations of this time course. In a typical flanker task, participants are asked to respond as fast as possible to a central target with 2 alternative identities that is presented together with 2 flanking distractors. Typically, when the target is flanked by incongruent distractors, whose identity is the alternative target, responses are slower than when the same target is flanked by neutral distractors whose identity is unassociated with neither motor response. We use the mutations paradigm to assess the time course of perceptual processing of distractors. And when I say perceptual processing, I mean the critical accumulation of visual information from a presented stimulus until it can be perceived. So, in the mutations paradigm, on each trial, while the target remains unchanged from onset until response, both distractors mutate once per trial, and after the mutation, the display remains on screen until response. So we had 3 types of trials, 3 types of mutations. Trials in which incongruent distractors mutated to neutral distractors, the opposite, neutral to incongruent. And our control trials were those where neutral distractors mutated to different neutral distractors. So we had these 3 kinds of trials, and the mutation itself occurred in 1 out of 8 alternative times after onset, between 8 and 67 milliseconds after onset. So we had these 3 kinds of trials mutated randomly in 1 of those times after onset. Let me give you 2 examples. So this is an incongruent to neutral trial mutated at 33 milliseconds. So the target never changes, remain unchanged until response. And incongruent distractors are presented within the initial 33 milliseconds, after which they are replaced by neutral distractors that remain until response. Another example, this is neutral to incongruent mutated at 17 milliseconds. Target never changes. Neutral distractors presented within the initial 17 milliseconds and then replaced by incongruent that remains on screen until response. So, the pre-mutation display is presented between 8 and 67 milliseconds, and then the post-mutation display is presented after the mutation until response, which is around 400 milliseconds depending on the trial. So in all trials that we'll see, the pre-mutation display is completely masked by the post-mutation display. So phenomenologically, participants saw only the post-mutation display, even for 67 milliseconds mutations. Here we have reaction time by the time of mutation. So these our neutral to neutral trials mutated at different times, and we'll compare these trials to the 2 other types of trials. Here we have incongruent to neutral trials mutated after 8 milliseconds, meaning that the incongruent distractors were presented for 8 milliseconds and then replaced by neutral distractors until response. Now, these 8 milliseconds presentation of incongruent distractors were enough to significantly delay responses by 13 milliseconds, which means that within those miser 8 milliseconds, the system accumulated enough information about those identities for them to be perceived. Later mutations, so prolonged presentations of incongruent distractors, increasingly delayed responses until a ceiling of delay of 25 milliseconds for 50 milliseconds presentations of incongruent distractors. Beyond 50 milliseconds, the delay did not increase, which means that the system continually accumulated information about distractors in incongruent displays at least until 50 milliseconds after onset. These are incongruent and neutral displays without any mutation. So this is a simple replication of the classic flanker effect. So when an incongruent display was presented from onset until response, it delayed responses by 40 milliseconds. When the incongruent display appeared only 8 milliseconds later, the delay already dropped by almost half, but remained highly significant. The same for 17 milliseconds. At 25 milliseconds, the delay dropped to 9, but still significant. But when incongruent distractors appeared 33 milliseconds after onset or later than that, they remained completely inconsequential. They were completely ignored. I remind you here, the neutral distractors were presented for 33 milliseconds and then fully masked by incongruent distractors that were presented for another 420 milliseconds, more or less. So phenomenologically, participants saw only the incongruent distractors, but their responses were determined by the neutral distractors. That means that in neutral displays, the system ceased to accumulate information about the distractors somewhere between 25 and 33 milliseconds after onset. Summarizing, here we have, again, reaction time. Here we have the effect sizes for these comparisons. The red asterisks and bars are the comparisons between the red and the black, and the blue between the blue and the black. Identities were perceived, or information about identities were accumulated enough for a perception after 8 milliseconds. Neutral distractors were processed exclusively within the initial 30 milliseconds, while incongruent distractors were continually processed until at least 50 milliseconds after onset. Now, we replicated these patterns in 2 additional experiments, both in Tel Aviv and in Vancouver, in SFU, also with inverted colors, the exactly same manipulations with inverted colors. We had, again, 8 milliseconds for the minimum accumulation of information for perception. Neutral distractors processed exclusively within the initial 30, 20, and 15 milliseconds. And incongruent distractors continue to be processed until much later, 50, 60 milliseconds after onset. Now, we can explain or interpret these patterns in 2 alternative ways. First, it's possible that the end of distractor processing observed after 60 and 20 milliseconds reflected de facto suppressions of the distractors, after which the system continued to accumulate information about the target only until it had enough information for a response. Alternatively, it's possible that the system accumulated all information it needed within the initial 60 and 20 milliseconds. So at those times, not only distractor ceased to be processed, but also the target ceased to be processed. We tested these 2 hypotheses by assessing the time course of target identification. So first of all, we measured accuracy for non-speeded responses instead of reaction times. And we used the exact same stimuli, but here there were no mutations. We presented either an incongruent display or a neutral display masked at different times after onset. The masking for incongruent or neutral displays appeared between 8 and 92 milliseconds after onset. The idea was that if the masking appears while the system is still accumulating critical information about the target, the masking should disrupt target identification. But if the mask appears after the system finished accumulating information about the target, the masking would remain inconsequential. So first of all, these are neutral displays. So in neutral displays, here we have error rates by the time of masking. The later the masking appeared, the less errors were committed, until a floor level of 4% errors when masks appeared 75 milliseconds after onset, after which the masking became inconsequential. That means that the system finished to accumulate information about the target when it was flanked by neutral distractors, somewhere between 58 and 75 milliseconds the latest. In incongruent displays, on the other hand, the masking remained effective until as late as 92 milliseconds after onset. That means that in incongruent displays, at 92 milliseconds, the system was still accumulating critical information about the target. Summarizing thus far, at the first stage, all stimuli were processed, followed by active suppressions of distractors, after which the system continued to process only the target until it has accumulated enough information for a response. And we also saw that in neutral displays, distractors were suppressed earlier, target information was accumulated earlier, and as usual, responses were faster. Now, most, if not all accepted interpretations of the flanker effect explicitly claim, or at least implicitly assume, that attentional selection in flanker tasks is predominantly, maybe even exclusively guided by spatial discriminations, meaning that targets and distractors are discriminated according to their relevant and irrelevant locations. Now, in all our experiments, in all trials and conditions, the spatial configuration was identical. The target was always at the center, at the same absolute location at the center of the screen, at the same relative position between the two distractors. All sizes, all distances were identical. It's hard to think of better conditions for spatial discriminations. Now, if distractors are discriminated according to their locations, and if spatial configurations were identical for all display types, how is it possible that neutral distractors were suppressed so much earlier than incongruent distractors? So we have a suggestion. In neutral displays, only the target had a task-relevant identity, while in incongruent displays, all the three identities were task-relevant, which means that neutral distractors could be recognized either according to their task-irrelevant locations or according to their task-irrelevant identities, while incongruent distractors could only be recognized according to their task-irrelevant locations. Now we saw that when distractors could only be recognized according to their locations in incongruent displays, the distractors were suppressed later than 50 milliseconds after onset. But when distractors could also be recognized according to their identities, they were suppressed 20 to 40 milliseconds earlier than that. And we also saw that the system had accumulated enough information for identification even earlier than that, within the initial 8 milliseconds after onset, which makes sense. We conclude that in our experiments, and possibly in flanker tasks in general, even though the system could fully predict all locations and all relative positions at all times, still the system recognized and suppressed identities much faster than it mapped and suppressed locations. Thank you very much.